Hello, in this section I will show you how to transform the Cartesian from cylindrical to Cartesian coordinates. So this is the vector from cylindrical coordinate system to Cartesian coordinate system, and we know that in cylindrical coordinate system the vector A can be represented as unit vector A rho, vector Ax plus unit vector A phi, vector A phi plus unit vector Az, vector Az. And in Cartesian coordinate system, vectors can be represented as unit vector Ax, vector Ax, unit vector Ay, vector Ay plus unit vector Az, vector Az. And we know that Ax is equal to vector dot product of we are calculating here, so Ax should be equal to A and unit vector Ax. So Ax will be equal to unit vector A rho, vector A rho plus unit vector A phi, vector A phi plus unit vector Az, vector Az, and the dot product with unit vector Ax. Similarly, we can write the vector Ay equal to unit vector A rho, vector A rho plus unit vector A phi, vector A phi plus unit vector Az, vector Az, dot product with unit vector Ay. Similarly, we can write the vector Az, unit vector A rho, vector A rho plus unit vector A phi, vector A phi plus unit vector Az, vector Az, dot product with unit vector Az. Now considering these dot products, we have Ax equal to dot product A rho, unit vector Ax, vector A rho plus unit vector A phi, dot product unit vector Ax, vector A phi plus unit vector Az, dot product Ax, vector Az, and vector Ay is equal to unit vector A rho, dot product unit vector Ay, vector A rho plus unit vector A phi, dot product A phi and unit vector Ay plus unit vector Az, dot product unit vector Ay, vector Az. And Az can be written as unit vector A rho, dot product with unit vector az vector arrow plus unit vector a5 dot unit vector az vector a5 plus unit vector az dot product with unit vector az and vector az. So these are the simplified equations and you can solve it as, so substituting the values of these dot product, we get ax equal to cos phi a rho minus sin phi a phi, and ay equal to sin phi a rho plus cos phi a phi, and az is equal to az. So we have the vector a is equal to unit vector ax in bracket cos phi a rho minus sin phi a phi plus unit vector ay cos phi a rho plus cos phi vector a phi plus unit vector az vector az. In matrix form you can write it as vector ax vector ay vector az. So you can write it as in a matrix form. This is cos phi and sin phi 0. This is minus sin phi cos phi 0 and 0 0 1. This is a rho, this is a phi, and this is az. So this is the transformation from cylindrical to Cartesian coordinate system, and this is the simplified way you can transform easily. So in next section I will show you the transformation between Cartesian and spherical coordinate system. Thank you.